Hello my dear students, today we are in lecture number 31 of second chapter, same unit, electrostat. Hopefully my dear students, today this would be last lecture of second chapter of NCERT. From Monday we'll start current electricity. Okay my dear students, I am B.S. Pandey. The student, as I got the several requests by the students to repeat the plates problem. So today first I will explain you with another way or the another method the plates problem, and then we will move to the next for balance Wheatstone Bridge and the some circuit. Okay, so let me discuss today with the plate problem. Plates problem. Okay, so my dear student, suppose directly I'm explaining here the concept with the example, the first example. Suppose this is a plate and this is connected by the positive terminal. This one is connected by the negative terminal. You have to find the equivalent capacitance of these plates. Here the space between the plates are air and the separation is D. A plate area is A. A is the area and D is the separation. Okay, now today I'm teaching you to solve this question. First, the same concept, you have to write the numbering 1, 2, 3, and then you have to give the polarity of charge. Okay my dear student, if it is positively charged plate, then plus and plus, and of course plus and plus. Here the middle one is negatively charged, so it will be negative. Now student, you can see 1 and 3 is connected. It means these two at same potential. So you will write 1 and 3 at one point. The connected, remember, due to these two are positive, that's why not we are writing here at one position, but these two are connected directly. Okay, it is connected directly, that's why I'm writing 1 and 3 at one point, and another point is 2. Okay, now we will arrange the plates, and this will be the easiest method that you can solve any plates problem. You can see due to this plus and minus, there's one capacitance between 1 and 2. So here is 1 and this is 2. So the one capacitor. Okay, I am representing here the one capacitor. Now between 2 and 3, you can see there is one capacitor. 2 and 3, where is 2? 2 is here and 3 is here. So the one capacitor in between these two. Now my dear student, this is C and this is C. Now find out the terminal. The terminal here between 1 and 3, the X terminal 1 and 3 is here, so the X, and the Y terminal from 2. Now this is very easy, you can see both are in parallel. So C equivalent will be how much? It is C1 plus C2. If C1 is epsilon, C1 C2 both are identical, that's why it is 2C, and C is what? Twice epsilon naught A by D. Okay, so this is answer. Again, take another example. Okay my dear student, suppose this is the plate. This is the plate. Now student, this is the terminal for the positive. Suppose the X, which is positive, and Y negative. You can take any one, positive or negative. Here also you can take any one, positive or negative. The answer will be same. Remember, answer not going to be changed my dear students. Now you have to give the numbering 1 to 3 and then positive negative. This is positively charged, so the plus plus, and here plus and plus. Now the negative one, here this one is the negative negative, here this one is the negative and negative. Now 1, 2, 3 and 4. Now find out which point are at the same potential. So 1 and 3 are connected directly. So the 1 and 3 we are writing. Now 2 and 4 connected directly. 2 and 4. So 1, 2, 3 and 4. We have all the points. Now the representation of plates. You can see between 1 and 2 there is one capacitor. So this is 1 and this is 2. Between 1 and 2, one capacitor. Between 2 and 3, one capacitor. 2 and 3, this 2 is minus and plus. So one capacitor. Remember, one capacitor we are considering actually due to plus and minus. Suppose if in any arrangement, if this is plus and this is also plus, there will be no capacitor. Plus and minus, that's why this is the capacitor. Minus plus, one capacitor. So between 2 and 3, one capacitor. 2 here and 3. So the one capacitor. Now between 3 and 4, where's 3? 3 is here and 4 is here. So another capacitor in between these two. Now find out the terminals. X from 1 and 3, 1 and 3. Y from 2 and 4, from 2 and 4 y. You can see easily these three are connected in parallel. So the C equivalent will be C1 plus C2 plus C3, that is the 3C. That is 3 epsilon naught A by D I-O. Okay. I hope students this would be a little bit easiest method. Okay, let me give you another question. If you understand, then try to solve by yourself, my dear student. Okay, now this one is the question of plate problem. This would be your classwork. Suppose this is X and this is Y. You have to find the capacitance. If you can solve, try to solve. Okay. Now look at here. 1, 2, 3 and 4. Now give the polarity. Suppose this is plus and this is minus. So plus, plus and minus, minus. Okay. Now due to this plus there will be minus and there will be plus. Due to this plus there will be minus and here will be plus. Okay. Now you have to arrange the points. Point 2 and 4 at one position. 2 and 4. Now 1. Now 3. I think it is finished. 1, 2, 3, 4. Okay, that's it. Now find out the capacitor. Between 1 and 2 there is one capacitor. 1 and 2, one capacitor. Between 2 and 3, between 2 and 3, one capacitor. Between 3 and 4, one capacitor. Between 3 and 4, one capacitor. Now find out the terminal from 1 X, from 3 it is second terminal, from 3 it is Y. Now if you will arrange this circuit, you will find, remember this is the flexible wires, so you can pull this one to this side in this way. If you pull this one this side, it looks like this one. This is X. Okay, my dear students, now I am erasing this one. Now you can see this is very easy. These two are in parallel and then it is in series. So this will be C of this one and this will become 2C. So the answer will be C equivalent. It is 2C times C divided by 3C. That is 2 over 3C answer. I hope student now you will not confuse while solving the plates problem. One I am giving you for your home assignment. Otherwise I have given you the home assignment. You can solve the number of question, but one question I am giving you here. Okay, so this is one plate and this is another plate. You have to find the capacitance of this network, my dear student. So this was the request of few students, that's why I repeated this particular topic. Now come to the next one. Today we are moving for balance Wheatstone Bridge. Actually it is the Wheatstone Bridge. Wheatstone has given a very fantastic circuit solution. Wheatstone Bridge. There are two types of Wheatstone Bridge. One, it is balanced Wheatstone Bridge, and another, it is unbalanced. Remember, this is the electronic circuits. It has nothing to take by with the mechanic. It is electronic circuit. So, my dear student, this particular topic we will study in very detail in the next chapter, that is electric current, but here I am explaining you the concept. The balanced Wheatstone Bridge structure will looks like. You will have, this is the terminal X and Y. You will have the 4-arm capacitor. Okay. And this one is the bridge. Okay. This is the 2-arm and 2-arm. And this is the bridge. This will also contain a capacitor. Alright. Now, my dear student, we will study the condition of balanced Wheatstone Bridge. Okay, in the next chapter. Here the two terminal. Suppose this is capacitor C1, C2, C3 and C4, and this is C5. So balance and unbalanced condition. For the balance, I am telling you the condition. If, remember, if C1 by C2 is equals to C3 by C4, C3 by C4, or C1 by C3 is equals to C2 by C4. Remember, this is the condition. If it is poses such condition, then this 2 point, if it is P and Q, then P and Q will be at same potential. Remember, at same potential. What does it mean? If P and Q at same potential, it means there will be no flow of charge by C5, and then the C5 can be vanished, can be taken out from the circuit. We can remove this C5 and then circuit looks like, final circuit looks like this one, and this will be the simplest one. You will be highly interested to solve such type of question based on balanced Wheatstone Bridge, my dear student. C1, C2, C3 and C4. Now you can see that the C5 is removed from the circuit. Now this was very difficult to solve, but now this is very simple. C1 and C2 are in series, C3 and C4 are in parallel. It means C equivalent will be now, here C1 and C2 are in series. It means C1 C2 by C1 plus C2, and this is also in series, and then finally in parallel. It means these two will sum up. So C3 and C4 by C3 plus C4, and this is the answer. Remember, so in this case this is very easy. This is the condition and this will be the final circuit. Okay, if it is balanced. If it is not balanced, then we will have some exercise. Okay, we will do such type of question. Remember students, I am showing here the few structure or the few balanced Wheatstone Bridge. Okay, We will talk about the balanced Wheatstone bridge and then we'll come to the unbalanced Wheatstone bridge, how we will solve unbalanced Wheatstone bridge. Okay. Okay, my dear students, look at here. The another one, which is the important, not very much. After a few example, you'll be able to write such type of note points. Remember, if a balanced Wheatstone bridge in this way, this is the X and Y terminal. Okay, this is the bridge one, bridge capacitor. If all the capacitors are identical, okay, and whatever this one, C1, C2, because finally it has to be removed from the circuit. If all the capacitors are identical, if you find all the capacitors identical in balanced Wheatstone bridge, then answer will be the either one capacitance. Okay, so the C equivalent will be C answer. Remember. Okay. Now another example. Here I am showing you the few balanced Wheatstone bridge. You have to tell me whether this is balanced Wheatstone bridge or not. Here I am taking the points X and Y. Okay. This is C, 2C, 2C, 4C. Whether this is balanced Wheatstone bridge. So now the next example. Kindly find out whether this is balanced Wheatstone bridge. The next one. Finally, I will tell you the answer. This one. The terminals X and Y. Suppose it is C, C, 2C, 2C, C. Whether this is balanced Wheatstone bridge? If yes, then what will be the final structure of this balanced Wheatstone bridge? Another one. Okay. This one. This one. This is the C, 2C, C, 4C, 2C. Whether this one is the balanced Wheatstone bridge. Okay, let me solve these three questions. Then after we'll move for the another Wheatstone bridge circuit. Okay. Whether this one is the balanced Wheatstone bridge, student? And the answer is yes, it is balanced Wheatstone bridge. C, this is the terminal. And about the terminal, you have to see the arm resistor. Okay. So the C by 2C, C by 2C, whether equals 2C by 4C, 2C by 4C, then you will find answer yes. This is also 1 by 2 and this is also 1 by 2. It means the ratio are same. Then what will be the answer? So the answer will be you have to remove this one. Okay. Bridge. Now answer C, 2C. So the C and 2C, here I am solving the question. This one C and 2C. So the C times 2C by C plus 2C. I'm sure that few students are able to solve this question directly with the very simple mathematical calculation. Here the 2C and 4C. So the 2C times 4C by 2C plus 4C. Okay. 2C plus 4C. Now solve here. It is 2, this C will be cancelled out. Okay. So 2 by 3C plus here 6 and this C will be cancel out. So the 2C is 2C divided by here the 2 4 8C divided by 6 and the answer is 4 and it is 3. So the 6C by 3, the answer will be 2C. I hope you got answer of this particular question. Now the second one, whether this one is the balanced Wheatstone bridge, my dear students. I am rubbing this one. Whether this one is the balanced Wheatstone bridge, and the answer is yes. This is balanced Wheatstone bridge. How it is? If terminal is here, then C by 2C, and which is equal to C by 2C, or C by C equals to C by 2C. So this will be removed. You can stretch this circuit by pulling down, then you will see this circuit looks like this one if we will pull down that circuit. Okay, in few circuit you have to train yourself that you need to pull or stretch the circuit to see whether this one is in balance condition or not. Okay, 2C and 2C. I hope you can solve. Now next one, this one. Yes, 2C by C. So 2C by C, whether this is equals 4C by 2C, 4C by 2C. Answer is yes, this is a balanced Wheatstone bridge, and the final circuit looks like this one. This will be removed. This two are in series, this two are in series, and then parallel. I hope you can solve this one, my dear student. Now I'm giving you few homework, and then we'll come to the unbalanced Wheatstone bridge. Okay, my dear student. Now look at here. This will be your homework. Okay. The first homework. By pausing the video, I am writing the homework because it will take some time. So, my dear student, these are the four homework. Look at here on this first one. Here the 5 microfarad. All the capacitors are given in microfarad. Remember, na? 5 microfarad, 5 microfarad, 5, 5, 10, 10. Okay. 5 and 5, 5 and 5, and then 10 this one and 10 this one. Now look at here. The C, 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 C and C, X and Y terminal. Here this one is the X and this is the Y terminal. Now look at here. Here this is not connected. Remember, this is not linked with this one. Okay, and this terminal is X and this is Y. Here C, C, 2C, 2C, 4C and C. You have to find the equivalent capacitance between terminal X and Y. Now the fourth one, you can see it is C, C, 2C, 2C, 4C, 4C, C and C. Terminal X and Y. So these are the four homework. Now my dear students, another example I am here discussing. Suppose this is the circuit, whether this one is the balance or unbalanced. Try to tell me the answer. C, 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 C and C. Whether this one is the balance or unbalanced, and what will be the answer. Okay, pause the video and try to solve. Now look at here for the answer. My dear students, actually this is not the Wheatstone bridge. This is the very simplest circuit. These two are in series, these two are in series, and then all the three are in parallel. So the answer will be these two are in series. It means C by 2 plus C, this one, plus these are two in series, C by 2, and this is the answer, that is the 2C. C equivalent will be 2C. Okay, this will be the answer. Now we'll come to the unbalanced Wheatstone bridge. How to solve the questions of unbalanced Wheatstone bridge if the bridge is unbalanced. So the one method already I have discussed with you. Today I'll discuss, okay, the both method I will recall you today, but the unbalanced Wheatstone bridge, this one. Okay, let me draw the circuit a little bit clear over here. A battery is connected over here. and this one is the bridge capacitor. These are the capacitors. Okay, now suppose this value is 2, 4 and 4. Yes, 4 and 2, and this is 2, and suppose the battery here, the V. Now whether this one is the balanced Wheatstone bridge or unbalanced Wheatstone bridge, the answer is yes, this is the unbalanced Wheatstone bridge. Now the question, how this type of question will be solved. So remember students, the one concept I have been explained already, charge distribution. Okay, so the charge distribution method 1, it is a charge distribution method. Charge distribution, suppose the Q charge start moving from the battery. This one is, suppose this is 10 volt. Remember here the 10 volt or 50 volt, the equivalent capacitance not going to be changed, only the charge of circuit will change. If you have been asked to find the equivalent capacitance, don't worry about the potential, what should we take, 10 volt, 100 volt, whatever may be the potential, equivalent capacitance not going to be changed. So you can take any potential over here if the terminals are given, don't worry about the potential. Now my dear students, the charge Q is moving. Okay, at this point the charge will divide in 2 points, suppose Q1 and Q2. This one is Q1 and this is Q2. At this point when the charge will reach, again the charge will have to break in 2 parts. Suppose Q3 is moving towards this one, or the Q3 it is moving towards this one. Due to the little split I'm writing at this one, the Q3. Okay, so what amount of charge will go along this one? Q1 minus Q3. Okay, now these are the direction of charge. Charge is coming from here, charge is coming from here. The both will sum up and goes in this direction, and here the charge is coming, the charge is coming, both will sum up and will come toward this one, and this will be equals to Q. Remember what is Q? Q actually break in 2 parts, Q1 plus Q2. Okay, you can see whether this distribution is correct or not. How you will solve? Using the charge distribution method, that is the method 1. So you will take 3 loops here, the loop 1, loop 2, and this one is the loop 3. Remember, to study the loop I'm writing here the A, B, C. I hope you will be able, if you are looking it from initial. Okay, A, B, C, D. Okay, and this is the battery V itself we will use as a symbolic name. Now loop 1, only I am giving you the name of loop, you will solve by yourself. So the loop 1, it is A, B, A, B, D, A, B, D, A. Now loop 2, or the name of loop 2, B, C, D, B, B, C, D, B. Now loop 3, this one, A, D, C, A, D, C, B, B and A. Okay, A, D, C, B and A. So these are the 3 loops. You will write the 3 equations, 3 variable you are having, then you can solve. Okay, you know in mathematics it is very, again I'm writing this circuit and I'm telling you the another concept. Okay, the another method to solve. You can solve this particular question by 7 to 8 method. Remember my dear students, 7 to 8 method you can use to solve such type of question. There is another method called the delta star conversion. Okay, due to sort of time I cannot explain over here, but in class program if you will ask, then I'll tell you. Okay, by sure. Now my dear students, again I'm pausing the video and drawing this particular network. Hey my dear students, so this was the circuit. Now we are going to study by the another method, and this method is called the potential divider method, method 2. Okay, method 2, potential divider method. This is called the potential divider method. My dear student, to use this potential divider method, remember you have to find the potential. Suppose potential of the circuit over here, it is 10 volt. What will the potential at this point? 0. What will be here? Of course 0 volt. Okay, potential at over 10 volt, over here 10 volt, over here again 10 volt. Okay, Do you know the potential over here? No, let it is X. Potential over here, you know? No, let it is Y. Now, we will use here the first law of Kirchhoff's first law. Now, my dear student, at this point, if we'll apply the Kirchhoff's law at X, KCL we are going to apply. Where? At X. So the charges are coming at X from three section, okay, from here and here. Suppose X at high potential. What will be the net charge at X? According to this law, net charge at X should be how much? 0. Okay, so what will be the charge? As we know that Q equals to CV. So at this point the Q will be C into V. And what will the potential here? The potential across this capacitor will be X minus 10. So 2 times X minus 10 plus 2 times X minus Y, 2 times X minus Y plus here 4 times X minus 0. 4 times X minus 0 is equals to how much? Equals to 0. Now you will solve, you will get an equation with X and Y. Okay. Now for this particular, at this point you will write again the same equation and you will find charge is coming from 3 section, 1, 2, 3, coming or going, it doesn't matter. We are taking this Y point at high potential. So the charge for this one, Q is equals to CV. C is 4. 4 times V, how much? Y minus 10 plus 2 times Y minus X. Y minus X plus 2 times Y minus 0. Y minus 0 equals to how much? This is 0. Equation 1. Actually, after solving, you will get the equation 1 and equation 2. And using that equation 1 and 2, solving X and Y, you will have the answer. Okay. I am pausing the video to write this value of X and Y so that we can save the time. We are already running out with the time. So this will be the equation 4x minus y equals to 20. Equation 1. And here 4y minus x is equals to 20. This two equation you will solve and you will get the value of x and y. Okay, now the question is how you will find the equivalent capacitance. Actually, by this method, students, you can find out the equivalent capacitance, even the potential across each capacitor, charge on each capacitor. Remember, if you are having the value of x, by x minus 10 you will have the potential across this one. If you are having the potential across this one and the potential capacitance is 2, then charge you will have. Okay, so you can find out the potential and charge across each capacitor by very simple method, this voltage divider method. Now equivalent capacitance, what should be the equivalent capacitance? So we know that, student, Q is equals to CV. Okay, CV, and C will be Q by V. What is the V? So V, already we are having 10 volt. It means we require to find the, we are finding here the charge. Okay, what will be the charge? So the charge, basically this battery is leaving the charge Q, which is dividing in two parts. It means you have to find the charge over this one and this one, and you will sum up the two charges. You will have the net charge of this circuit. Here the charge will be how much? It means after knowing the value of x and y, you will find the charge over here. Suppose it is Q1 and charge over here, suppose it is Q2. By adding this Q1 and Q2, this will be Q dividing V. You will get the equivalent capacitance. Okay, my dear student. So this is the voltage divider method. I am giving you one, okay, homework. You will solve by yourself. I am rubbing this one, my dear student. You will solve this particular question as a homework by both the method. Okay, potential divider and charge distribution as well. So the first question, actually one question I'll give you by this one. Okay, the simple question I'm giving you. Two, 4, 2, 2. Okay, and the 10 volt. You have to find equivalent capacitance of this network and charge across each capacitor and potential across each capacitor. Okay, you have to find. This is your homework. So this is all about the question, and the few questions I'm giving you for the homework. This one is the first one. Second, This question student were asked in CBSC. That is the very important question. Kindly note down this question. Okay. This is also your homework. This is the plate arrangement. This question is being asked 1 year in IIT also. Few years ago. Plate area is A. Separation, suppose it is D between these two plates. This length is also D and this length is also D. Remember, this is D. You have to find equivalent capacitance between X and Y if such type of arrangement. If I'll give you the plate straight here of this much space, then you can find easily the equivalent capacitance, but the arrangement is a little bit different. You have to find the equivalent capacitance of this network, and a few questions I'll give you, okay, in homework. Thank you, my dear student.